topic is metallurgy. We'll do some objective questions on metallurgy. Question number 1. Which of the following is called philosopher's wool? 4 different ores are given and you have to find out which one is called as philosopher's wool. Option 1 is zinc sulfide ZNS, option 2 ZnCO3, option 3 ZNO, and option 4 is CuFeS2. And the correct answer is ZNO, third option, ZNO. Zinc oxide is called philosopher's wool popularly because it has a woolly appearance. So for question number 1, the correct answer is option 3, that is zinc oxide. Zinc oxide has woolly appearance, therefore it is called as philosopher's wool. Question number 2. Identify the correct match. The first option is magnetite Fe3O4. Second option is zinc side ZNO. Third option is cuprite Cu2O. And fourth option is siderite FeS2. And the answer is siderite FeS2. Actually, siderite is FeCO3. It's a carbonate ore of iron. So the incorrect match is siderite FeS2. Siderite is actually FeCO3. The correct answer therefore is fourth option. Question number 3. Removal of gangue from an ore is known as? First option concentration, second option isolation, third option roasting, and fourth option is calcination. Gangue is also called as matrix. Removal of this siliceous impurity from the ore is called as concentration of ore. So the correct answer is concentration, ore minus gangue. This process is called as concentration of ore. Removal of gangue from the ore is called as concentration. Correct answer is first option, concentration. Question number 4. Identify the chemical method from the following methods of ore dressing. Number 1, levitation. Number 2, magnetic separation. Number 3, froth flotation. Number 4 is leaching. So among these 4 methods, first 3 methods are physical methods of separation and the fourth one, leaching, is the chemical method. See, in levitation what we do is we run a stream of water on the powdered ore. Heavier particles remain there and lighter particles are washed away along with water. So this is a physical method of separation. Magnetic separation, this is based on difference in the magnetic nature of ore and impurities. You use magnetic rollers and magnetic impurity sticks to that and non-magnetic impurity is removed. Then you have froth flotation. This is also based on wettability of ore and impurities. Ore is wetted with oil and impurities are wetted with water. So it's a physical method of separation. Whereas in leaching, for example, I'll show you leaching of gold. You take gold particles in water and add cyanide and you pass air also, oxygen of air, and you get AuCN taken twice. So this is a chemical method because you can see Au got oxidized to Au plus and it has formed a soluble complex. So this is an example of leaching of gold in the extraction of gold. So the correct answer therefore is fourth option. Leaching is a chemical method of ore dressing. Now question number 5. Identify the correct match. First option, hydraulic washing is for sulfide ores. This is not true actually. For sulfide ores we go for froth flotation. Second option, froth flotation, oxide and carbonate ores. This is also not correct. Third option, leaching, silver and gold. Fourth option, magnetic separation, is silicates. Actually, the correct answer is third option. Leaching is done for extraction of silver and gold. As you know, we have just now seen for silver Ag2S, we add sodium cyanide in presence of water and aerial oxygen. Then we get AgCN taken twice minus plus Na2SO4. This is leaching. This is how leaching is done for silver extraction. And for gold, Au plus Cn minus plus oxygen of air, of course water also should be present, and then you get AuCN taken twice minus. So this is how leaching is done for these two extractions, extraction of silver and gold. So the correct match is third option, leaching is done for silver and gold. Question number 6. Identify the incorrect statement from the following in froth flotation method. Number 1. Froth carries gangue particles. It's not true. Actually, froth carries ore particles. Froth carries mineral particles. This is a correct statement. Froth collectors enhance the non-wettability of mineral particles. Fourth option is mineral particles become wet by oils while gangue particles become wet by water. So we are asked to find out incorrect statement. So the incorrect statement is first option, froth carries gangue particles. This is incorrect. Actually, froth carries ore particles. So the correct answer is first option. Question number 7. Which of the following acts as depressant in the froth flotation process? Depressant in froth flotation process. Option 1, copper sulfate. Option 2, KCN. Option 3, cresol. And option 4 is aniline. And the correct answer is second option, KCN. Let's find out. When you are concentrating PBS, ZnS is present as an impurity. So we add sodium cyanide. Sodium cyanide will form a soluble complex with ZnS. With PBS, there is no reaction. So when you are concentrating PBS by froth flotation technique, add sodium cyanide. That will take care of ZnS impurity. It will be transformed into a soluble complex, and ZnS will not be able to stick to the froth. Only PBS will stick to the froth, and in this way it is possible to concentrate PBS in presence of ZnS. So the correct answer is second option, KCN. KCN acts as a depressant for ZnS during the concentration of PBS. Question number 8. In the reaction, 4Ag plus 8Cn gives 4AgCN taken twice plus 4OH minus, and then AgCN taken twice is treated with some X. This will give Y and silver, and we have to identify X and Y. This is an extraction of silver from its ore. So the correct answer is third option. What happens is AgCN taken twice reacts with zinc. Zinc is an active metal. It is more active than silver, and you get a soluble complex of zinc. And silver is precipitated. So the correct answer is third option. X is Zn, this is X, and this is Y. Question number 9. During metallurgy, the removal of non-fusible impurities from the ore becomes easier by the addition of number 1, option 1 flux, option 2 slag, option 3 matrix, and option 4 is mat. And the correct answer is first option, flux. So what happens is flux reacts with gangue and you get a easily fusible substance, slag. For example, SiO2 is added as a flux if the gangue is calcium oxide, and you get calcium silicate as slag. So the correct answer is therefore first option, flux. Flux is a substance which removes gangue from the ore. Question number 10. Identify an acidic flux among the following. Option 1, calcium carbonate, option 2, magnesium carbonate, option 3 is ferric oxide, and option 4 is SiO2. And the correct answer is SiO2. SiO2 is an acidic oxide and therefore acts as an acidic flux. It removes basic gangue material. The same equation what we have just now seen, calcium oxide plus SiO2. If this is gangue, this will act as a flux and you get rid of this as calcium silicate. This is slag. So the correct answer is fourth option, SiO2 is an acidic flux. Question number 11. Copper matte is a mixture of, first option Cu2S and FeS, second option CuS and CuFeS2, third option CuO and FeS, fourth option is Cu2O and FeO. The correct answer is Cu2S and FeS. This mixture of Cu2S and FeS, this mixture is called as matte. Question number 12. Ellingham diagram provides the basis of, first option, the choice of reducing agent in the reduction of metal oxides in the extraction of metals. Number 2, the choice of oxidizing agent for the conversion of metal, the rate of reduction of metal oxide into the metal, and fourth option is all the above. Well, the correct answer is choice of first option, that is choice of reducing agent in the reduction of metal oxide in the extraction of metals. We have already said that a metal can reduce another metal oxide if it is present below it in the Ellingham diagram. So you can make a proper choice of reducing agent for reduction of a particular metal oxide. You need to see to it that delta G for the overall reaction should be negative. So the correct answer is first option, that is Ellingham diagram provides a basis for making a choice of reducing agent to reduce a particular metal oxide. Question number 13. Ellingham plots are graphs of, first option, standard free energy versus pressure, standard free energy versus delta S, standard free energy change versus delta H, standard free energy change versus T, absolute temperature. The correct answer is fourth option. It is a graph plotted for standard free energy of formation of metal oxide against temperature. So answer is fourth option. Question number 14. The term coupling of reactions means, first option, the point of intersection in Ellingham diagram, second option, carrying two spontaneous reactions simultaneously, number 3, carrying both spontaneous and non-spontaneous reactions simultaneously, number 4, getting a very large positive Gibbs free energy chain. The correct answer is third option. Coupling is something which involves joining of two reactions, one spontaneous and one non-spontaneous. The spontaneous reaction, its large negative delta G value will make non-spontaneous reaction proceed spontaneously. So it's a case of joining of two reactions, one spontaneous, that is with delta G negative, another one non-spontaneous with delta G positive. We need to see to it that the overall delta G becomes negative. So that's called as coupling. So the correct answer is third option, carrying spontaneous and non-spontaneous reactions simultaneously is called as coupling. Question number 15. Which of the following statements is correct? First option. Any metal would reduce the oxide of other metal which lie below it in the Ellingham diagram. Any metal would reduce the oxide of other metal which lie above it in the Ellingham diagram. Third option. Carbon would reduce the metal oxide if it lies above the metal oxide in Ellingham diagram. Fourth option. All the above. So the correct answer is second option. Any metal would reduce the metal oxide of other metal which lies above it in the Ellingham diagram, because you have more active metals at the bottom and less active metals at the top in the Ellingham diagram. So any metal would reduce the oxide of other metal which lies above it in Ellingham diagram. That means a more active metal can reduce oxide of less active metal. Correct answer therefore is second option. Question number 16. For the formation of most of the metal oxides, the slope of the Ellingham diagram is positive. This is because for the reaction, delta S is positive. Second option, delta S is negative. Third option, delta S is 0. Fourth option, delta S is 1. Actually, if you see formation of metal oxide, metal is a solid. It reacts with oxygen, which is a gas, to give metal oxide, which is a solid. So for this reaction, delta S is negative because gaseous substance combining to give solid product. So delta S is negative, therefore the slopes are positive. So the correct answer is second option. Question number 17. If it is difficult to reduce metal oxides to the metal using carbon, the reduction is done by first option, carbon monoxide, second option, carbon disulfide, third option, hydrogen, fourth option, electrolytic method. And the correct answer is electrolytic method. More active metals cannot be reduced by carbon reduction under ordinary conditions. So more active metals are therefore reduced electrolytically, like sodium, magnesium, aluminum. These are obtained by electrolytic reduction of their molten salts. So the correct answer is fourth option. If it is not possible to reduce a metal by carbon, then it is better to use electrolytic method. Question number 18. Slag formed in the extraction of copper is first option, CaSiO3, second option, MgSiO3, third option, FeSiO3, and fourth option is Na2SiO3. The correct answer is FeSiO3, third option. Let's see how it happens. CuFeS2 is the ore of copper. It consists of Cu2S and Fes. So during the extraction of copper, Fes undergoes oxidation preferably to give FeO. Of course, you get SO2, and then FeO combines with SiO2 to give FeSiO3, ferrous silicate. This is the slag which is formed during the extraction of copper. So the correct answer is third option, FeSiO3. Question number 19. The sulfide ores are first converted into their metal oxides before they are reduced into metals by carbon. This is because, see, metal sulfide is first changed to metal oxide. Then it is subjected to reduction with carbon or carbon monoxide and you get metal. Now the question is, the sulfide ores are first converted into their metal oxides before they are reduced into metals by carbon. This is because, first option, metal oxides have lower melting point than metal sulfides. Second option, metal sulfides, all metal sulfides are unstable beyond 1000 Kelvin. Third option, metal oxides are stable. Fourth option is metal sulfide is less reactive towards carbon than metal oxide. This is the correct answer. Actually, metal oxide, when it reacts with the carbon, you get carbon monoxide, which is a gas. We don't have a corresponding substance. Carbon monosulfide is not available. So this reaction is not feasible. So the correct answer is metal sulfide is less reactive towards carbon than metal oxide. The reason is Cs, an analogous compound, analogous to CO is non-existent. Correct answer is fourth option. Question number 20. The iron obtained from blast furnace is called. First option pig iron, second option cast iron, third option wrought iron, and fourth option both cast iron and wrought iron. The correct answer is pig iron. The molten iron, when it comes out from the blast furnace, is filled in some containers, and those are called as pigs. That's why the term pig iron is used. So the correct answer is first option. Question number 21. Which of the following metal oxides and sulfides undergo auto reduction to give metals? First option mercury copper, second option silver lead, third option mercury copper lead, and fourth option is mercury copper lead antimony and silver. The more correct answer is fourth option, which includes most of the metals which are obtained by auto reduction. Auto reduction is a process where a metal sulfide reduces its own oxide. CuS plus Cu2O gives copper plus SO2. If a metal sulfide reduces its own oxide, then it is called as auto reduction. So the correct answer is fourth option. Mercury, copper, lead, antimony and silver, these can undergo auto reduction. Question number 22. Removal of silica impurities from bauxite mineral is effected by option 1 Hoops process, option 2 Bayer's process, option 3 Hall-Hérold's process, and option 4 is Serpek's process. And the correct answer is Serpek's process. See, white bauxite is a mixture of alumina and silica. This mixture is heated with coke in an atmosphere of nitrogen gas. Alumina is reduced to aluminum nitride. This becomes silicon. Carbon monoxide escapes out. This also escapes as volatile fumes. So what is left out is ALN. ALN is then hydrolyzed to get aluminum hydroxide, and then it is ignited to get alumina. So this is Serpek's process of purification of bauxite, and we use coke and nitrogen. So the correct answer is Serpek's process, fourth option. Question number 23. In the extraction of aluminium, alumina is mixed with cryolite. The reason is, first option, to increase the electrical conductivity, second option, to serve as a solvent, third, to lower the melting point, number 4, all the above. And the correct answer is all the above. Alumina is a bad conductor and its melting point is also very high. To overcome these two problems, basically, we add cryolite. Cryolite makes it melt at a lower temperature of about 900 degrees Celsius, and it increases the electrical conductivity of the mixture. So the correct answer is fourth option. Question number 24. Metals having their own oxides as impurities are refined by, first option electrolysis, second option zone refining, third option poling, and fourth option is liquation. And the correct answer is poling, third option poling. Example is copper. When you get blister copper that consists of some copper oxide as impurity, we stir it with green wooden poles, green wooden logs, and the hydrocarbons present in the wooden poles will reduce the metal oxide to metal. So this is a very old technique called as poling. Question number 25. Crude form of metals like zinc and mercury are purified by option 1 distillation, option 2 poling, option 3 liquation, and option 4 is electrolysis. See, zinc, cadmium and mercury, these metals have very low boiling points. Because their boiling points are very low, they can be purified by distillation. So the correct answer is option 1 distillation. The reason is low boiling point. Question number 26. In a refining method, The impure metal is heated on the sloping hearth of a furnace. The metal melts and flows down, leaving behind the infusible impurities on the hearth. This refining method is called option 1 zone refining, option 2 vapor phase refining, option 3 liquation, and option 4 is pooling. The correct answer is liquation. Liquation is a process where low melting metals are purified. A very popular example is tin. Tin has a very low melting point, so it can be purified by liquation. You put it on a sloping hearth of a furnace and you heat it from the bottom. Then what happens is metal melts and flows down, the infusible impurities, which is called as dross. It will be left out on the surface of the hearth and the molten metal will come down, leaving behind impurities. This method is called as liquation, applicable for low melting metals. So the correct answer is third option. Question number 27. In the electrolysis of blister copper, the anode mud does not contain option 1 silver, option 2 selenium, option 3 gold, option 4 zinc. The correct answer is option 4 zinc. The reason is zinc being more active metal, it will dissolve in the electrolyte. It will dissolve in the electrolyte, it will pass into the electrolyte as Zn2 plus, it will not fall down as anode mud. Whereas the other metals, gold, silver, selenium, they fall down as anode mud. Zinc passes into electrolyte solution as Zn2 plus. This is the reaction which takes place. Zn reacts with cupric and you get Zn2 plus and copper. This passes into the solution, will not fall down as anode mud. Answer is fourth option. Question number 28. The method which is based on the principle that the impurities are more soluble in the melt than in the solid state of the metal is. Impurities are more soluble in the melt than in the solid state. First option vapor phase refining, second option zone refining, third option electrolytic refining, fourth option is pooling, and the correct answer is zone refining. See, here you get ultra pure metal. The metal is made into a rod and a circular heater is used for heating it. The heater is made to pass from one end to the other. All the impurities are driven to one corner, which is discarded. So this is called as zone refining. When you are passing the heater, this is heater, circular heater. When you are passing the heater from left to right, the molten part of the metal also moves in one particular direction and it will carry the impurities to one corner, and this corner is discarded. The correct answer therefore is second option, zone refining. Question number 29. The semiconductor grade metals of very high purity like silicon, germanium, boron, gallium and indium are purified by first option zone refining, second option vapor phase refining, third option pooling, fourth option electrolytic refining, and the correct answer is first option zone refining. Zone refining can be used to get ultra pure metals which can be used for making semiconductors. Any small impurity, any small amount of impurity can cause lot of changes in the electrical properties of the substance. So it is very important that the substance should be ultra pure. Zone refining is the technique which can be used to get ultra pure substances. Answer is first option. Question number 30. The assertion is all ores are not minerals, but all minerals are ores. Actually, this statement is not correct. Actually, all ores are not minerals. This is an incorrect statement. All ores are minerals and all minerals are not ores. All ores are minerals. Anyway, next reason, a mineral which is chemically and commercially viable for the extraction of metal is called an ore. This is correct. Ore is that mineral from which metal can be extracted easily and economically. It is commercially viable. So the correct answer therefore is fourth option. A is not true, but R is true. So fourth option is the correct answer. Question number 31. Assertion is hydraulic washing is based on the difference on the specific gravities of the ore and gangue particles. This is a true statement. Lighter particles will flow down. Those are particles of impurities which flow down along with water. Now the reason, heavier ore particles settle down rapidly at the bottom while the lighter impurities are washed away with water. So the correct answer therefore is first option. Both A and R are true. R is the correct explanation. So when you do washing, the lighter particles of impurity flow down along with water. They are washed away. Heavier ore particles stay back, and in this way it is possible to concentrate the ore. So first option. Question number 32. Froth flotation process is specially suitable for sulfide ores. It's a fact. Froth flotation process is suitable for sulfide ores because sulfide is hydrophobic, therefore it is wetted with oil. Reason, the impurities present in the sulfide ores are lighter than the metal. Actually, this is not true. It is based on the fact that sulfide is wetted with oil and the impurities are wetted with water. So it has nothing to do with lighter or heavier particles. So the correct answer is third option. A is true, but R is not true. Third option. Question number 33. The reduction of a metal oxide is easier if the metal formed is in the liquid state at the temperature of reduction than in the solid state. It is easier to reduce a metal if it is formed in the liquid state than in the solid state. That is what the statement is telling. Then the second statement, reason, the value of delta S of the reduction process is more on positive side when the metal is in the liquid state. Yes, it has something to do with entropy of the system. Delta S will be more positive if the metal is formed in the liquid state. So it is easier if at the reduction temperature metal is formed in the liquid state, then delta S will be largely positive and therefore it will become spontaneous process. Answer is first option. Question number 34. Some processes are given and you are asked to find out what chemical change takes place in a particular process. Roasting, smelting, calcination and levication. These four processes are given. On the other side you have decomposition, hydraulic washing, reduction and oxidation are mentioned. See, roasting is a process which involves oxidation because roasting involves heating in plenty of oxygen, and smelting is a process which involves reduction because you mix ore and the reducing agent and you put it in the blast furnace, you do smelting, reduction takes place. And then calcination involves decomposition. If it is a carbonate ore, it is broken down into oxide or oxide. So calcination involves decomposition. Levication is nothing but hydraulic washing. So the correct answer is fourth option. A is matched with 4, that is roasting is matched with oxidation. B is matched with 3, that is smelting involves reduction. C, calcination is matched with 1, that is decomposition, and D, levication is hydraulic washing. So the correct answer is fourth option. Question number 35. Again matching question. Leaching of silver and gold, calcination, roasting, sulfide ore of copper. These are the items given in list 1, and in the list 2 you have reverberatory furnace, regular supply of air, limited supply of air, cyanide process. Now leaching of silver and gold, it involves cyanide process because we use sodium cyanide. So leaching of silver and gold. A, silver for example, it reacts with cyanide in presence of water, in presence of oxygen, and you get AgCN taken twice minus. This is leaching. So it involves cyanide. So A should be matched with 4. Then calcination. Calcination is nothing but heating. Calcination involves heating in limited supply of air. Heating in limited supply of air. Then you have that means calcination should be matched with third option. And then roasting. Roasting is done in a regular supply of air. It is a heating done in a regular supply of air. C, roasting, heating in regular air supply. And finally, what is given is D, sulfide ore of copper. Sulfide ore of copper is taken in reverberatory furnace for roasting. So the correct answer therefore is third option. Question number 36. Some refining methods are given and you are given metals on the other side. You have to match a correct refining method used for a particular metal. Number 1, A is Mond's process. We know Mond's process is a case of vapor phase refining and applicable for nickel. Nickel is purified by Mond's process, wherein nickel is made to react with carbon monoxide. You get nickel tetracarbonyl. This is then decomposed to get pure nickel. This is Mond's process. Then you have Van Arkel method. Titanium is purified by this technique. Titanium is made to react with iodine and you get TiI4, and then this is heated to recover pure titanium. This is Van Arkel technique of purification. This is also a case of vapor phase refining. And then zone refining. Silicon and germanium, they are subjected to zone refining because you want them in ultra pure state, as these are used in semiconductor devices. Then vapor phase refining, D, vapor phase refining, you can match it with either titanium or zirconium. Both the possibilities are there. So the correct answer is fourth option, that is A is matched with 2, that is Mond's process is matched with nickel. B is matched with 3, Van Arkel is for zirconium, and then C is matched with 4, that is zone refining is matched with silicon and germanium, and vapor phase refining D is matched with titanium. This is the possible answer from the options. So the correct answer is fourth option. With this, we have come to an end of discussion on questions on metallurgy. Thank you.